Hello, my name is Christopher Howard, and welcome to my talk. This is basically an introduction to the built-in Emacs calculator, properly known as EmacsCalc, particularly from the perspective of someone with a technical background such as engineering or electronics. I will say, though, my personal interest is not really in digital computing or digital calculators, but lately has been focused more on analog computing. I have, for example, been working to master the venerable slide rule, a mechanical computer that calculates multiplication, powers, and logarithms. Here's a picture of one. It's a physical tool that was used for hundreds of years for this sort of thing before the handheld calculator was made popular. And I also had a project that I did for a while several months to build an electronic analog computer. So, a rudimentary attempt of mine, but it's functional, and it's basically a 1960s or 1970s style electronic analog computer, built very much on a budget, but the box in the middle is the computer proper, which has most of the components inside of it, as well as the potentiometers for setting values, and an operation switch. There's a patch panel on the left for connecting the different integrators, amplifiers, multipliers, and so forth together. And then the output of the simulation is displayed on the oscilloscope on the right side, which is a digital oscilloscope. And to be honest, I think that a talk about analog computing would be much more interesting than the talk that I'm about to give. But unfortunately, that would be out of scope for Emacs conference. So instead, I will talk about EmacsCalc, the digital calculator built into Emacs. EmacsCalc, while not being a replacement for software like GNU Octave, does have advanced calculator functionality that can be useful in engineering, electronics, or other technical applications. So I don't want to oversell it, but I think functionality-wise, calc is somewhere in between what you'd expect of a decent scientific calculator and an advanced graphics calculator. So this talk, I'll mention, is not intended to be a tutorial, but only a brief introduction to calc. So please refer to the built-in calc info manual for detailed instructions on how to complete operations. Turn off my volume here. So the documentation for EmacsCalc is built in, although on some distributions you may have to install the Emacs documentation separately for licensing reasons. Calc presents itself as a stack-based calculator, where entries are dropped onto a stack, and then an operation is performed on the stack entries. So, for example, I can drop 1.23 onto the stack, and then 8.56, and then multiply them together. However, so calc does present itself as a stack-based calculator, But indeed, calc is also capable of accepting input in the more well-known algebraic format by using the calc-algebraic-entry command, which by default is bound to the apostrophe key. So you type the apostrophe key, enter the algebraic input, including parentheses as needed. So, for example, here's a calculation of the resonance frequency of a coil, which has an inductance of 250 microhenries and 160 picofarads, taken from one of my electronics handbooks. So the formula for that is 1 over 2 pi, and then the square root of our inductance, which is, in this case, is 250 microhenries, and then the capacitance, which is 160 picofarads. Small typo here. Now I need to evaluate that one more time because pi is a symbol. And I get about 800 kilohertz resonant frequency. The command calc-roll-down, which by default is bound to the tab key, will swap the top two stack entries, which is sometimes useful if you need to manipulate something that's further down the stack. So I can swap this around and say multiply it by 2, and then put it back where it was. This command is also capable of rolling the entire stack. So say I want to shift them all around. This can be done by passing extra arguments to the calc-roll-down function. That's a little bit inconvenient to do manually. So in my init file, I defined here a function that, or a key definition that passes in those arguments correctly. And I attach this to Shift tab. So this way I can roll the entire stack. Then I could change one entry here and then put it back where it was. So calc does algebraic input. It also does advanced functions that you would expect any handheld scientific calculator, including trigonometric functions. So, for example, we can get the sine of a number. Now, I'll mention here that calc has multiple modes. Right now it's in degree modes. You can switch over to radian modes if you want. I'm going to put it back in degrees. Drop 12 degrees on the stack, and then get the sine of that. And then with the inverse sine function, I can put it back. Calc also has the nifty ability to solve equations for you, so long as the equation's not too complicated. But this is using the calc-solve-for function. So, for example, we could enter in an equation algebraically. Then run calc-solve-for, and we just have to tell it what variable we want to solve for. And there we go. We can do this manually as well, just so you can see that we'd get the same result. Calc is also able to solve systems of equations. So we can put more than one equation on the stack and then solve for several variables. To give a technical example for this, I'll show you a resistor network scribble that I did recently. Hopefully you can see that, but basically it's a pretty simple resistor network with 1 kilo ohm and 10 kilo ohm resistors, and using the loop methods, we are calculating the currents, the current in each loop, and then that current can be used to solve for the voltage of each individual resistor if we want to. So at the bottom there we have the equations that we come up with as we work through each loop. And I'm going to paste that into calc. To save some time, I'm going to copy and paste that from my notes instead of typing it out. So we have two equations there on the stack in one stack entry. And we run that solve-for function again. And we tell it which variables we want to solve for. And voila, those are our currents, which we can then use to get the voltages for the individual resistors. And I'll just briefly mention that if calc is not able to solve an equation with calc-solve-for, then you might be helped by another calc function called calc-find-root. This function basically does a manual search for a numerical solution to the equation. And there's the documentation page on that. Calc can also solve or find derivatives of functions, at least the more straightforward functions. So for a simple example, we can get the derivative of that with the derivative function. And on the other hand, calc is also able of figuring out indefinite integrals. So say we put that function back on the stack, and this time we call the integral function. And there you go. Of course, you have to add your own constant of integration. For integrals that calc cannot figure out symbolically, a numerical integration method is available through the calc-num integral command. Which is documented, the function documentation is available here, more or less. And I definitely need to mention that calc is capable of doing programmable functions. That is to say, you can program your own functions into calc. There are three separate ways to do this. One is through a macro method, similar to Emacs' usual keyboard macros. The second method is to transform an algebraic function into a stored function definition. And the third is to use eLisp directly. Personally, I find that the second method is the most practical. the most convenient and practical, in my opinion. And so I'll give a quick example of that. So I could, let's say I wanted to have a function for calculating capacitive reactance. So I'll define that in algebraic mode first. So the function for that is 1 over 2 pi, the frequency and the capacitance. Drop that on the stack. You see it does automatically get simplified a little bit, but it's the same function. And then I press the letters Z and F. Excuse me, do that again. Z and F to start transforming that into a stored function. It asks me to select a user key, a single key press that I can use for that. I'll use the letter C. Then it's going to ask for a longer command name. I've actually defined this once before, so it pre-filled in that that command name. And then I need to enter which variables in the formula are actual arguments, rather than just symbols to be evaluated later. I prefer to put this in with frequency and the capacitance after that, but actually in this particular case, it doesn't matter at all to the mathematics. So I can now, all I have to do that this is defined is I can drop the frequency on the stack, which we'll say for this example will be 4.5 megahertz, and then drop on the capacitance, which in this example will be 22 picofarads. Then I'll call the function that I just defined. I don't really like having to try to remember the short letters that I've come up with, so I'll just use the longer name. And I need to evaluate one more time because the symbol pi is in there and not yet evaluated. And so if I've done that right, we have a capacitive reactance of about 1600 ohms. And as the last feature that I'll mention here, EmacsCalc does have an interface with GNU-plot if you want to have calc work as your graphing calculator. I do need to be honest and mention that I don't generally use it myself because there's another program in GNOME that I've found to be generally more convenient for the things that I want to graph quickly. But I think I can give you a simple example. So first we need to drop a range on the stack. Let's say 0 to 10. And then we need to drop the function on the stack. And then I believe it's the letters G and F that graph this. Let's see. Yep, there we go. So there's our function, and it looks nice. That was pretty easy. That's the fast way to do it. I will, as a disclaimer, mention that using this quick approach, that sometimes more complicated graphs will not turn out nicely because by default the resolution will be pretty low. That is to say, GNU-plot is going to be skipping a lot of points, and so you'll have to learn a bit more about how to use the interface, what parameters to pass. if you want all your graphs to come out looking nice. So that covers all the features that I wanted to cover. I wanted to briefly mention a wish list of items that I'd like to see in calc. One of them would be improper integrals. So that's like our definite integrals, except for where a limit of integration is infinity. That's something that can be useful in a few applications. Something else that would be neat to have would be annotations for row entries. So, for example, if I was putting together a sum of numbers for, say, my monthly budget, let's say I was paying $2,000 for my rent, and let's say $800 a month for my groceries. A lot of kids to feed there. And then say another, let's say $60 for dining out, and so on. It would be nice if there was some way to put a little annotation next to each number so that you could remember what the meaning of that number was more easily. I actually looked into programming this into calc myself, but discovered that that it would require reprogramming quite a bit of calc to make that work well across all calc functionality, and so eventually I gave up. But I'd still really like to have that feature. The final thing, though, I think this would not necessarily belong in calc. I think it would be cool if Emacs had some way to run numerical solutions for systems of differential equations, also known as a differential analyzer. So this would allow you to be able to set up simulation models involving systems of differential equations, for example, a spring mass system or pressure temperature or what have you, and then run the simulation using numerical approximation. And maybe it would be silly to actually put that in calc itself, but a nice interface maybe to some other software, simple software that did that, an easy to use interface for that would be really great. So that's my entire talk. I'll just mention some information if you want to learn more about me or things that I'm interested in. I do not any longer have a web presence. I don't have a website anymore, but I do have a Gemini capsule that I post to all the time. And if you're willing to install the Gemini browser known as Elfer into Emacs, which is available from ELPA, then you can browse directly to it and look around my Gemini capsule. So, thank you very much.